Hello everyone, so in this video we will be discussing the total differentiation. Previously we have discussed the partial derivatives of an equation. So now we'll be discussing how to get the total differentiation or total derivative of an equation. So the total differentiation dz of a function z f of x y is given by dz, the letter D, z, which is equivalent to partial derivative of z with respect to x plus partial derivative of z with respect to y. Similarly, the function u, which has the variables x, y, and z, is given by u is equivalent to partial derivative of u with respect to x plus partial derivative of u with respect to y plus partial derivative of u with respect to z. So basically, we'll just add all the partial derivatives of an equation so that we'll get the total differential of the function. So this symbol, the dz over dx, is called the total derivative of z with respect to x. So if we are tasked to find the total derivative of z with respect to x, we have to use the bold letter d here. Unlike in partial derivative, we need to use this kind of symbol. So, for example, if u is equivalent to the function of x, y, and z, the total derivative of u with respect to x is given by du over dx, which is equivalent to partial derivative of u with respect to x plus partial derivative of u with respect to y times dy over dx, or derivative of y with respect to x, plus partial derivative of u with respect to z times the derivative of z with respect to x. So if you can observe, since we are getting the du over dx, so from here we can cancel this, and what will be left is in terms of u and in terms of x. So that's how we can get the value of our total derivative of u with respect to x. So for example, we have here, if z is equivalent to x squared y, x, where x is equal to t squared, y is equal to 2t, we need to find the total derivative of z with respect to t in terms of t. So from this one, in order for us to find the dz over dt, we still have to find, or we still have to solve for the partial derivatives of the equation. So for the first partial derivatives, we have dz, partial derivative of z with respect to x. So from here, we need to take y as constant. So what we're going to derive is just the x. So derivative of x squared is 2x. Then since y is constant, so you just have to copy that. And for the partial derivative of z with respect to y, we have derivative of y is 1 times the constant x squared. So that is just x squared. And take note, we have a value for the x and the y here. So we'll be substituting that to the derivative, or to the partial derivative that we have got. So from here, this would become 2 times the value of x, which is t squared, because again, we are deriving in terms of t, times y, which is 2t. So basically, this is equivalent to 4t cubed. And then the same with the partial derivative of z with respect to y, we have x, which is t squared, and that is squared, so this is equivalent to t to the fourth. So these are the partial derivatives of our z with respect to x and y. Now, we also need to find the derivative of our x and the y. So, as we know, x is equivalent to t squared. So the derivative of x with respect to t is equivalent to 2t. The same goes with y. Y is equivalent to 2t. So the derivative of y with respect to t is just equivalent to 2. Now, why do we need to get these derivatives of the x and the y? Because we need to find the total derivative of z with respect to t. So the total derivative of z with respect to t is just equivalent to partial derivative of z with respect to x times the derivative of x with respect to t plus partial derivative of z with respect to y times the derivative of y with respect to t. So if you can observe, can cancel this. So what will be left is the dz and the dt. So that we can get the total derivative of z with respect to dt. Now substituting the values for the partial derivative of z with respect to x, that is equivalent to 40 cubed, and multiply with the derivative of x with respect to t, which is 2t, plus the partial derivative of z with respect to y, which is t to the fourth, times the derivative of y with respect to t, which is 2. So basically this is equivalent to 4 times 2, that's 8t to the fourth, plus 2t to the fourth, or this is equivalent to 10t to the fourth. So this is now the total derivative of z with respect to t. Okay, I hope you understand this one, and I hope you understand when to multiply the derivative of the values that we have. Next is we have to find the total derivative with respect to t and in terms of t. So from here, so first, in order for us to find that, is we still have to find the partial derivatives of each of the variables that we have in the equation. So we have partial derivative of u with respect to x. So from here, the first term has a variable x. So derivative of x is 1 times the constant ln(y). So this is ln(y) plus z, which is constant, times the derivative of ln x, which is 1 over x. And for this one, since this has no variable x, meaning to say this is constant. So next one, we need to find the partial derivative of u with respect to y. So from the equation, we have x is constant times ln y, or times the derivative of ln y, which is 1 over y. And this one will be constant because it has no variable y. And for the third term, y ln z, y is the variable, ln z is the constant. So derivative of y is 1, and copying the constant, which is ln z. Next one is the derivative of u with respect to z. So for the first term, it has no z, so that's 0. Now for the second term, we have z ln x. So z ln x, the derivative of z is 1 times the constant value, which is ln x. So this is equivalent to ln x plus y, which is constant, times the derivative of ln z, which is 1 over z. Okay, so simplifying this or substituting the values of our x, y, and z, we have ln y is t squared, so ln of t squared, plus our z, which is 40, all over our x, which is t. So basically, we can cancel this. So that this is equivalent to ln t squared plus 4. Okay, the next one is substituting the values of the x, which is t, over y, which is t squared, plus ln of z, which is 4t. So cancel 1t from the numerator and the denominator. So we have 1 over t plus ln of 4t. Next one is ln of x, which is ln of t, plus our y, which is t squared, all over our z, which is 4t. So cancel one of the t here in the numerator. So we have ln t plus t over 4. Okay, so after we got the partial derivatives of our equation, then we also need to find the derivatives of the x, the y, and the z. So from here, our x is equivalent to t, so the derivative of x with respect to t is just equivalent to 1. For the y, we have t squared, and the derivative of y with respect to t is equivalent to 2t. And for the z, we have 4t, and the derivative of z with respect to t is equivalent to 4. Now, finding the total derivative is we have du over dt. Total derivative of u with respect to t. So that is equivalent to partial derivative of u with respect to x times derivative of x over dt plus partial derivative of u with respect to y times derivative of y with respect to t plus partial derivative of u with respect to z times dz over dt. Okay, so substituting the values that we have du over dx, or partial derivative of u with respect to x, is ln t squared plus 4 times the derivative of x with respect to t, which is 1, plus partial derivative of u with respect to y, which is 1 over t plus ln 40, times the derivative of our y with respect to t, which is 2t, plus the derivative of u with respect to z, which is ln t plus t over 4, times the derivative of z with respect to t, which is 4. Okay, so again, you have to multiply it. You have to multiply the derivative so that what will be left in the equation is all du and dx. So if you cancel this, so what will be left is du, and then dt. Okay, so simplifying our equation or simplifying our answer, we have ln t squared plus 4, 1 over t times 2t, that is plus 2. 2t times ln 40, that is 2t ln 40. ln t times 4, that is 4 ln t. T over 4 times 4, that is just equivalent to t because we can cancel the 4. Now simplifying further, combining like terms, we have 4 plus 2, that is 6, plus we have the t here. Then we also have 2t ln 40. We also have plus 4 ln t plus ln t squared. So as we know, for this one, for applying the property of the natural logarithm, we can put the exponent before our natural logarithm. So this would become 6 plus t plus 2t ln 40 plus 4 ln t plus 2 ln t. Now we can combine this already. 4 plus 2, that is 6. So this would become 6 plus t plus 2t ln 40 plus 6 ln t. So we cannot simplify this any further, so this is now our final answer. Okay, so we have second example, which is still to find the total derivative with respect to t and in terms of t. So earlier, since it says that it's in terms of t, then there's no need for us to change the value of our answer into the given values here because it says that it's in terms of t. But if it does not said that in terms of something, meaning to say you have to replace it to its original value. Okay, so we have the next example. We have z is equivalent to sine xy, where x is equal to t and y is equivalent to e raised to t. So the same process, we still have to find the partial derivative of z with respect to x, which is derivative of sine, which is cos xy, times the derivative of our angle xy. So in terms of x, so this is equivalent now to taking x as constant. I mean taking x as the variable. So our answer is just equivalent to y. So our final answer is y cos xy. Next is the partial derivative of z with respect to y. So we have derivative of sine is cos xy, taking y as our variable and x will be constant. So the derivative of that is equivalent to x, because again the derivative of y is just 1 times the constant x, which is x. So we have x cos xy. So now, after we got this one, after we got the value of our partial derivatives in terms of x and y, we need to substitute now the values of our x and the y. So we have y is equivalent to e raised to t cos t e raised to t. And then for this one, we have t cos of t e raised to t. Okay, so after that, we can derive now the values of our x and the t. So derivative of x with respect to t is just equivalent to 1. Derivative of y, which is e raised to t, is just equivalent to e raised to t. Okay, so finding the total derivative of z, total derivative of z in terms or with respect to t, this is just equivalent to partial derivative of z, partial derivative of z with respect to x times derivative of x with respect to t plus partial derivative of z with respect to y times the derivative of y with respect to t. So substituting the values, we have derivative or partial derivative of z with respect to x is e t cos t e t times our dx, which is 1, plus partial derivative of z with respect to y is t cos t e t times the derivative of y with respect to t, which is et. Okay, so simplifying our answer and factoring out the common, we have et e raised to t cos t e raised to t is common from both terms. So we have, for this one, that's 1. And then this one is plus t. So this is now our final answer. So we have here our third example, which is to find the total derivative with respect to x. So for this one, since it does not say that in terms of something, meaning to say we need to replace our final answer with the original value of our given. So from here, there's no need for us to change the variable t into x and the y because it says here that it's in terms of t. So later on, we'll be replacing it to the original value because it does not say that it does not state or specify that we have to find in terms of x or in terms of a variable. Okay, so still the same process. We still have to find the derivative of z, but now it's with respect to x. So partial derivative of z with respect to x is equivalent to a derivative of this one. Derivative of x is 2x over x squared plus y squared. Next is the partial derivative of z with respect to y. So the derivative of y here is 2y divided by the original value of our ln, which is x squared plus y squared. Now simplifying the equation, since we are finding the total derivative with respect to x, only the y is given, so that it would be in terms of x, totally in terms of x. So we have 2x all over x squared plus our y, which is sine x squared. And for the partial derivative of z with respect to y, so we have 2 sine x all over x squared plus sine x squared. So after that, we have to find again the derivative of our y with respect to x. So we have dy over dx. Sine x, the derivative of that is cos x. Okay, so in order for us to find the total derivative of z with respect to x, we have dz over dx, which is equivalent to partial derivative of z with respect to x. And since there's no need for us to cancel the dx here in the denominator, so meaning to say we cannot or we will not be multiplying anything to partial derivative of z with respect to x. Instead, we'll be adding the dz or the partial derivative of z with respect to y. And since we are canceling the partial derivative y here, we need to multiply that with dy over dx. Okay, so that we can cancel this, and what we have left is dz and dx. Okay, so substituting now the values, we have partial derivative of z with respect to x is 2x all over x squared plus sine squared x plus the partial derivative of z with respect to y, which is 2 sine x over x squared plus sine squared x times the derivative of our y with respect to x, which is cos x. So again, we can simplify this one by factoring out what's common. So the common between two terms is 2 over x squared plus sine squared x. So we have 2 over x squared plus sine squared x times what we have left here, which is x, plus sine x and cos x. So since again, as I've told you earlier, since we are not finding the total derivative in terms of any value, meaning to say we need to replace it back again to the original value. Since sine x is equivalent to y, meaning to say our answer is also equivalent to x squared plus y squared. Sine x is equivalent to y, and this is squared, so that is y squared times x plus sine x is equivalent to y, so we have to replace that back to y times cos x. Okay, so this is now our final answer. The last example for this video is to find the total derivative with respect to x from the equation z is equivalent to x over y, where x squared plus y squared is equivalent to 4. So here, this is just our equation, and these are the value that is given. So from here, we still have to find the partial derivative of z with respect to x, which is equivalent to 1 over y, because x is the variable, 1 over y is constant. Derivative of x is just 1. So 1 times 1 over y is just 1 over y. Next is partial derivative of z with respect to y. That is equivalent to y is our variable, so we can use the quotient rule, or you can also use the product or the power rule. So from here, we can y times 0 minus x times 1. Quotient rule, using the quotient rule, over y squared. So cancel this. So what we have here is negative x over y squared. Now, substituting the value of our y, because we are looking for the total derivative with respect to x. So from this equation, we have x squared plus y squared is equivalent to 4. So we need to find the value of our y here by working with this equation. If we move x squared to the other side of the equation, we have y squared is equivalent to 4 minus x squared. And since we are looking for the value of the y alone, we have to square root both sides. So meaning to say y is equivalent to square root of 4 minus x squared. Okay, and for the partial derivative of z with respect to y, we are looking for y squared. So meaning to say y squared is just equivalent to 4 minus x squared. Okay, so these are the values that we'll be going to substitute to our partial derivatives. So that being said, 1 over y will become 1 over square root of 4 minus x squared. And for negative x over y squared, that is equivalent to negative x over 4 minus x squared. Okay, and then afterwards, we have to find the derivative of our y in terms of x. So again, our y is equivalent to this one. Y is equivalent to square root of 4 minus x squared. And in order for us to find the derivative of that in terms of x, we can change this one into exponential form. So this would become 1/2 of 4 minus x squared raised to negative 1/2 times negative 2x. Canceling 1/2 and 2. So our dy over dx is negative x over square root of 4 minus x squared. Okay, so that is our dy over dx. So finding the total derivative of z with respect to x is basically equivalent to partial derivative of z with respect to x plus partial derivative of z with respect to y times the derivative of y with respect to x. Substituting the values, we have 1 over square root of 4 minus x squared plus we have, that should be minus x square root of minus x over 4 minus x squared times the derivative of y with respect to x, which is negative x over square root of 4 minus x squared. Okay, so we have 1 over square root of 4 minus x squared. Negative times negative, that is positive x squared over 4 minus x squared raised to 1 times 4, square root of 4 minus x squared is basically equivalent to 4 minus x squared raised to 3/2 because 1 plus 1/2 is 3/2. Now, since as you can see, these are composed of two fractions, we can combine the fractions by finding the LCD. So the LCD of this one is 4 minus x squared raised to 3/2. So what is missing from here is just 4 minus x squared plus this one, which is x squared. So basically, 4 minus x squared plus x squared is just equivalent to positive 4 over 4 minus x squared raised to 3/2. Now, if you can remember, the value of our y is equivalent to square root of 4 minus x squared. So we need to change this back in terms of y for this one. So basically, this is just equivalent to 4 over square root of 4 minus x squared raised to 3, because 1/2 times 3/2, that is just equivalent to 3. So basically, square root of 4 minus x squared is just equivalent to y. So meaning to say our final answer is 4 raised to y cubed. I hope you learned something from this video, and I'll see you on the next videos.